This lesson is for day 4 of Unit 3, Section 2. We're going to be covering the textbook section 3.4. This section is about the quadratic formula. And the quadratic formula is a way to solve for x. It always works for every single quadratic equation. And it's going to give us the solutions x equals the opposite of b plus or minus the square root of b squared minus 4ac, and the entire thing is over 2a, not just the square root part, but the entire thing, which means we have to do the entire top before we worry about dividing by the bottom. Before we get into solving with that, though, there's something called the discriminant, and the discriminant is the part underneath the square root. That is actually going to tell us how many solutions we have and what types of solutions those are. So if I end up with a positive discriminant, that means I'm taking the square root of a positive number, right? When you take the square root of a number, you get the positive and negative of that. So that means there's going to be two real solutions when the discriminant is greater than 0. If the discriminant equals 0, that's like taking the square root of 0. And the square root of 0 is just 0. So there's only one thing happening there, which means we only end up with one real solution. And we've been talking a lot about the fact that when we take the square root of a negative number, it's not allowed. And we're still going to wait before we officially talk about that. But what happens is we actually end up with something called an imaginary number. That's why we have the word real. We also have the word imaginary. So if it ends up being less than 0 or a negative number, that means there's really two imaginary solutions. And once we learn about imaginary numbers, we'll actually solve for some to get the imaginary solutions. But just for now, know that if we get a discriminant that's negative, it means that there are two imaginary solutions. Notice here on the graphs, it crossed it twice for two real solutions. It just touched it here, crossed it once for one real solution, and it never crossed the x-axis at all for two imaginary solutions. Before we described it as no real solutions, now we're going to go with two imaginary. So what we're going to do first is we're going to find the discriminant so we can determine the type of solutions and how many there are. All right, so let's start. Let's make it a little smaller here. So I'm going to identify my a, b, and c because I know I'm doing b squared minus 4ac. That is the discriminant formula. So a in this case was 1, b was negative 6, and c was positive 10. So when I plug this in, it's negative 6 being squared. I'm going to keep parentheses around that. Minus 4 times a, which was 1, times c, which was 10. All right, anytime I plug a number in, I'm going to stick it inside parentheses. So this is 36. And now I'm going to look at the signs first. I have one negative all the way across, which means I'm going to have a negative here. 4 times 1 is 4, times 10 is 40. So 36 minus 40, we get negative 4. That's a negative discriminant, so there are two imaginary solutions. Okay, on the next one, we have A is 1, B is negative 6, and C is 9. So, all right, come on. I hit something and I don't know what. Oh boy. Okay. So I'm going to have negative 6 squared minus 4 times 1 times 9. So this is 36. Again, only one negative all the way across, so minus 4 times 1 is 4, times 9 is 36. So we have 36 minus 36, which is 0. So 0 means that there's one real solution. All right, and now let's look at part C. I have A is 1, B is negative 6, and C is 8. So we're going to have negative 6 squared minus 4 times 1 times 8. So that's 36. Again, one negative, so it's minus. 4 times 1 is 4, times 8 is 32. So that gives me a discriminant of 4, which is a positive number. So there are two real solutions. So you go ahead and try these 4. You can pause it and I'm going to show the answer. All right, so those are our answers here. All right, for number 2, it's okay that we had a fraction here, right? Because when I did b squared minus 4 times a times c, this 4 times a half just became 2, right? So it was 1, 2 negatives was plus, 2 times 1 is 2, and that's how I got 3. We can also use the concept of the discriminant to determine what values a and c would have to be in order for it to have a specific type of solution. So in this problem, we want to know what values of a and c for this particular equation would give us one real solution. So what we're going to do here is we know that b squared minus 4ac has to equal 0 in order for there to be one real solution. And I know that b is 3, so that's the only thing I get to plug in. So I have 3 squared minus 4ac equals 0. So that's really 9 minus 4ac equals 0. I'm going to add 4ac to both sides. And now I'm going to get ac alone by dividing by 4. So that's 9 over 4 equals ac, or 2.25 equals ac. So what I'm looking at is I want to know what two numbers I can multiply to give me 2.25. We're going to pause here for a second. Okay, so I realized my problem. My directions are wrong. It should not be one real solution. Just going to change things a little bit. I knew there was something off there. This direction should actually say two real solutions. All right, so let's adjust. Now for my discriminant, instead of being equal to 0, two real solutions is positive, so it's greater than 0. So I'm going to go back to this, greater than 0. So now I have 9 minus 4ac is greater than 0. If I move the 9 over, right, we get negative 9 now. I'm going to divide by negative 4. Remember when you divide an inequality by a negative, it flips. So now it's positive 9 over positive 4, because negative over negative is positive, and the inequality symbol flipped because of that. So I have a times c is less than 2.25. This makes more sense because I need integer values, only whole numbers. So I need to find two numbers that multiply to something that's less than 2.25. I could do 1 times 2. 1 times 2 is 2, which is less than 2.25. I could do any positive number times any negative number, because that'll give me a negative number, right? I could have 65 times negative 40, and that's going to be less than 2.25 because that's a negative number. So really anything that's a positive times negative would work, or the numbers 1 and 2 would work. Let's stick with the 1 and 2. So that means we can call A1 and C2. I could have called A2 and C1, and that's fine as well. So now I'm just going to rewrite the equation. So that'd be 1x squared plus 3x plus 2 equals 0. And this equation should have two real solutions. You're going to try the next one, and the next one is the one that wants one real solution. So go ahead and give that a try, pause it, and I'll show the answer. Okay, so we would have had 4 different possible combinations. If you chose any one of these 4, you would be good. We just had to have the product be 4. So if I, let's say, chose the 1 and the 4, that'd be x squared minus 4x plus 4 equals 0. Okay? All right. Now we're going to solve using the quadratic formula. So when I go to solve using the quadratic formula, I want to make sure it's equal to 0 first. I'll label my a, b, and c. It helps to find the discriminant first, because if I have a negative discriminant right now, I'm going to stop the problem because I can't go any further. I don't know how to solve with a negative square root. If I do have that, and it's positive or 0, then I'll be able to figure out how many solutions there are, and then I could use it to actually solve. So here's our first problem. Right, not equal to 0 yet, so I'm going to add 40. So that's 2x squared minus 11x minus 40 equals 0. So my a is 2, my b is negative 11, and my c is negative 40. So doing a quick b squared minus 4ac, right, the discriminant, that's negative 11 squared minus 4 times 2 times negative 40. So that's 121. I have 2 negatives here, so it's going to be plus. 4 times 2 is 8. 8 times 40 is 320. So I actually have a discriminant of 441. So that tells me I'm definitely going to have 2 real solutions. So if I go to now substitute this into the quadratic formula, I've already done that b squared minus 4ac part. So I'm going to write it out first. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So if I substitute in the opposite of b, so that's the opposite of negative 11 is positive 11, plus or minus the square root of, I already found that, 441, and the whole thing is over 2 times a, which was 2. So the quadratic formula looks a lot less intimidating once I've already found that b squared minus 4ac, right? I don't have to have a bunch of stuff under there. It's just now 441. So now I'm going to have 11 plus or minus, and if I take the square root of 441, I'm not going to draw that again. If I take the square root of 441, I get 21. And 2 times 2 is 4. So what this means is I have 2 answers, 11 plus 21 over 4, and 11 minus 21 over 4. So 11 plus 21 is really 32, and 32 over 4 is 8. So far x equals 8. And 11 minus 21 is negative 10. Negative 10 over 4 is the same as negative 5 over 2, or negative 2.5. And those are my answers for this equation using the quadratic formula. Let's try another one. All right, let's get it equal to 0 first. So minus the 5. So we know that a is 1, b is 3, and c is negative 5. We'll do the discriminant. So that's 3 squared minus 4 times 1 times negative 5. 9. I have 2 negatives, so that's a plus. 4 times 1 is 4, times 5 is 20. So we get 29. So there are 2 real solutions again. So now when I plug it into the quadratic formula, we're going to get opposite of 3 is negative 3, plus or minus the square root of 29 all over 2 times 1. And there's nothing I can do here. I can't reduce anything. I can't simplify it. So my answer can stay as negative 3 plus or minus the square root of 29 over 2. And that's it. That's an answer. If I wanted to turn that into decimals, I could. I would do, in my calculator, negative 3 plus the square root of 29, and I would hit equals, and then I would divide that by 2, and that gives me 1.19. And then I would do negative 3 minus the square root of 29, hit equals, and then divide that by 2, and I get negative 4.19. So whatever answer you're more comfortable giving, that's fine. But again, no work to be done here, so that's fine. We can leave it as that. Let's do yet another one together. So I'm going to have to add 2x first and add 1. So I have 9x squared minus 6x plus 1 equals 0. So a is 9, b is negative 6, c is 1. So we'll start with the discriminant. So that's going to be negative 6 squared minus 4 times 9 times 1. It's positive 36. Only one negative sign. 4 times 9 is 36, times 1 is 36. And this time I get 0. So that means I'm only going to get one answer, right? It's a repeated solution. So when I go ahead and substitute in for opposite of b plus or minus square root of b squared minus 4ac all over 2a, that's going to be opposite of negative 6 is positive 6 plus or minus the square root of 0 all over 2 times a, which is 9. So this is 6 plus 0 and minus 0 doesn't change it. It just stays 6 over 18, and 6 over 18 is 1/3. And that's our answer for that one, right? A lot less work to do there. So I want you to try the last 3. You can pause, and I'm going to show the answers. All right, so let's check our answers here. For 6, the discriminant was 49, so there were 2 real solutions, negative 1 and negative 8. For number 7, the discriminant was 0. There was only one answer, x equaled negative 1. And for 8, 65 was the discriminant, so we had 2 real solutions, but I couldn't reduce that. So it was 5 plus or minus square root of 65 over 2. And if I turned it into decimals, I would have had about 6.53 and negative 1.53. And that is our lesson on the quadratic formula.